It's pretty wild to think that almost 50 years later, Voyager 1 and 2 were still out there.
Yeah.
Still kind of pushing the boundaries for us.
Yeah.
So today, we're going to deep dive into those spacecraft.
Okay.
Especially some of the recent news about, well, them powering down some of their instruments.
Right.
And we've got a recent article from NASA about this. And
Yeah.
we've also got like a broader overview of the whole mission to give us a little context. It's really amazing what we're still learning all these decades later, right?
Absolutely. Yeah, and I think that, the fact that they're venturing into interstellar space, a region where, the sun's influence has basically stopped, makes them even more valuable.
Right.
I mean, there's nothing else human-made that's ever gone that far out.
It's so crazy to think about, right?
Yeah.
Like we just sort of threw these bottles into the cosmic ocean.
Right.
And they're still sending back messages. To be clear, though, they're not like shutting down entirely, are they?
No, no, no. They're just turning off a couple of instruments on each one, just to kind of help conserve power. So NASA is being strategic about this to extend their lifespan even further, maybe even into the 2030s.
Wow.
Yeah.
So it's kind of like, I guess, like a calculated trade-off, right?
Right.
You lose a few data streams now,
Right.
but you keep the mission going longer.
Exactly.
So what are the biggest implications of losing data like this? I mean, what kind of unique insights are we going to miss out on as these instruments go quiet?
Yeah, that's a great question. And it's a really tough decision every time they have to turn off an instrument. Like, for instance, Voyager 1's cosmic ray subsystem, that's being shut down. Well, that played a really key role in confirming that it had crossed into interstellar space.
Right, because that instrument could measure the increase in cosmic rays when you leave the sun's, like, protective bubble.
Right, the heliosphere.
Yeah, the heliosphere, exactly.
So what about the other instruments that are still working? What are they telling us about, like, the environment out there in interstellar space?
So each Voyager still has a working magnetometer, which measures magnetic fields. Okay.
And that's crucial for understanding, the structure and the dynamics of the interstellar medium, the vast space between stars.
Okay.
And there's also the plasma wave subsystem, and that can actually detect waves in the thin gas of charged particles that make up interstellar space.
So even with some of them powering down, we're still getting all this incredible data about, the fundamental forces and particles that shape the universe.
Right.
What does that tell us about the ingenuity of the original design?
Yeah.
The fact that these systems have lasted this long.
Yeah, it really is. It speaks to how talented the engineers were that designed and built these probes.
Yeah.
And remember, this was back in the 1970s.
Oh, wow.
And they were initially just meant to last 5 years.
Really?
Just to study Jupiter and Saturn. Nobody could have predicted that they'd still be going strong almost a half-century later,
Wow.
let alone that they would make it to interstellar space.
It really is built to last, isn't it?
Yeah.
I guess when it comes down to it, though, even the most robust systems have their limits.
Yeah, unfortunately.
Right.
Yeah, that's true. So,
The Voyagers are powered by these things called radioisotope thermoelectric generators, or RTGs for short,
okay.
and they use heat from decaying plutonium,
Okay.
and that's what creates electricity.
Wow.
It was a pretty ingenious system, especially for the time, but that plutonium decays steadily.
Right.
And so the Voyagers lose about 4 watts of power every year.
So it's almost like a slow but very real energy countdown.
Exactly.
So what factors go into deciding, which instruments to shut down, and how does that make you feel as someone who I'm sure follows this stuff closely?
Oh, it's a constant balancing act. I mean, scientists have to weigh the value of the data that each instrument is collecting against, the need to save power.
Right.
Each decision is really difficult.
Yeah. Because, it means we're losing a unique window into this uncharted territory. And it's kind of a stark reminder of how, these missions are finite.
There is a certain, poignancy to it.
Yeah, it's kind of like saying goodbye to old friends one by one.
Yeah. There was one little detail in the NASA article that really stood out to me. It takes over 23 hours for a signal to reach Voyager 1 from Earth.
Wow.
Which means we can't, control it in real time, right?
Yeah, that's right. It really highlights how much autonomy they had to build into these probes from the get-go.
Right.
I mean, they have to make decisions and adjust course, all without constant input from Earth.
So they're not just exploring space. They're almost thinking for themselves out there.
Yeah, kind of.
On the edge of the unknown.
Yeah, and that's what allowed them to keep going.
Right.
All this incredible foresight back in the 70s.
Right.
And to make it as far as they have.
It really is. That's brilliant engineering.
Yeah.
Makes you wonder what they're encountering now, what mysteries they're unraveling, and we won't even know for almost a full day.
It's really fascinating to think about.
Yeah.
Each little bit of data they send back is like a message in a bottle, carrying secrets from so far away.
Yeah. So we've talked about why this powering down is necessary.
Yeah.
But let's dig a little deeper into these specific instruments themselves.
Oh, okay.
So can you tell us about, like the cosmic ray subsystem on Voyager 1, the low energy charged particle instrument on Voyager 2? What did we learn from those before they had to be switched off?
Well, the cosmic ray subsystem on Voyager 1, as we talked about, was key in confirming that heliopause crossing.
Right.
But it also provided a lot more information than that.
Okay.
It gave us crucial data on the density and energy of cosmic rays, in both the heliosphere and out in interstellar space.
Wow.
So it's helped us understand, the galactic neighborhood we live in. And Voyager 2's low-energy charged particle instrument, well, that one was really important for measuring the various ions and electrons and cosmic rays, coming both from our solar system
Okay.
and, from the galaxy.
So it seems like every instrument is a story in itself.
Yeah.
Even as they go offline, all this data they've collected is going to be studied and analyzed for years to come, right?
Absolutely. The Voyagers have given us, a treasure trove of information that will keep scientists busy for generations. It makes you wonder what other discoveries are kind of hidden in that data,
Yeah.
just waiting for us to dig them out.
I like that. That's a perfect segue to our next point, which is to look at some of the incredible discoveries these Voyagers have already made.
Right.
So let's shift gears a little bit. We'll
Yeah.
move on to the next chapter
Okay.
in this incredible saga
Sounds good.
and explore these groundbreaking observations
Yeah.
that have really reshaped our understanding of the solar system and beyond.
I'm ready when you are.
Let's go. So it's mind-boggling to think that while disco was all the rage here on Earth,
Yeah.
the Voyagers were setting off on this journey.
Right.
That would totally rewrite our understanding of the solar system.
It's remarkable. They weren't just sightseeing missions, I mean, they really shifted how we understand planetary science.
Yeah. So let's talk about some of those groundbreaking discoveries. What were some of the biggest, most unexpected things that came out of the Voyagers' encounters with all the planets?
Oh, there are so many. It's hard to pick.
Yeah.
But I think, if we're talking about things that were really game changers,
Okay.
we have to start with Jupiter's moon Io.
Okay.
Before Voyager 1 flew past it in 1979, I mean, we pretty much thought all moons were just these cold, dead rocks.
Okay.
But Voyager showed us that Io is incredibly volcanically active.
Oh, wow.
Plumes erupting hundreds of kilometers high.
I remember seeing those images.
Yeah.
It was like something out of a movie. What did that tell us about the forces at play in our solar system?
Well, I mean, it completely changed our understanding of how moons can be shaped.
Right.
Not just by their planets, but by internal forces, too. We realized that that the tidal forces from Jupiter's gravity were creating all this friction inside Io.
Okay.
And that's what generated the heat for those crazy volcanoes.
Wow.
It really opened up this whole new realm of possibilities for what moons could be like.
That's so cool. And I bet Saturn's rings were a pretty big highlight.
Oh, absolutely. I mean, before Voyager, we knew Saturn had rings,
Right.
but we had no idea how beautiful and complex they were.
Yeah.
Voyager gave us those first detailed images.
Yeah.
Thousands of tiny ringlets, gaps, even shepherd moons that help, shape and maintain those structures.
I feel like those pictures, those are so iconic.
Yeah.
They really captured the public's imagination. Saturn's rings. It's just like a symbol of the beauty and mystery of space. So what about, the ice giants,
Yeah.
like Uranus and Neptune?
Right.
They're so far out, they must have had some surprises.
Oh, yeah. I mean, those planets were basically uncharted territory
Right.
back then.
Yeah.
And the Voyagers did not disappoint.
Yeah.
I mean, one of the most striking things was this thing called the Great Dark Spot on Neptune.
Okay.
This huge storm system, kind of like Jupiter's Great Red Spot.
Yeah.
But even more dynamic and shorter-lived. It really showed us that even those far-out planets are incredibly active.
Wow.
Constantly changing.
It's amazing. We were getting these glimpses into these worlds that were total mysteries just a few years before.
Yeah, it's amazing.
And then, of course, there's the whole Interstellar mission,
Yeah.
which is still going on.
Right. That's probably the most profound part of the Voyager's story.
Yeah.
They've gone from planetary explorers to like pioneers, you know,
Right.
crossing the heliopause, going into interstellar space,
Right.
which no other spacecraft has ever done.
It's incredible. So I read somewhere that the data that they're sending back from interstellar space is challenging some of our assumptions about what that region is like.
Yeah, definitely.
Could you tell us a bit more about that?
So, I mean, we used to think of interstellar space as being pretty calm, like mostly empty.
Okay.
But the Voyagers are showing us it's a lot more dynamic than we thought.
Oh, wow.
I mean, they've detected like fluctuations in the magnetic field,
Oh.
unexpected interactions between like the solar wind and interstellar particles,
Right.
even variations in the density of the interstellar medium itself.
So even as they're powering down, they're still changing our textbooks,
All right.
giving us this like new view of our galactic neighborhood.
Yeah, for sure. And it makes you wonder what other surprises are like hidden in the data they've already sent back,
Yeah.
just waiting for us to find them.
So speaking of, the data,
Yeah.
I can't help but think back to those early days when the technology was so limited.
You're
It
right.
just blows my mind. Like, how did they manage to, navigate and operate these complex spacecraft
Yeah.
with what we would consider primitive computing power today?
It really speaks to how brilliant the engineers and the programmers were
Yeah.
who worked on these missions. They had to be so creative, develop all these innovative solutions
Yeah.
and anticipate problems that might not even pop up for years or even decades.
Can you give us any like specific examples of the challenges they faced
Sure.
and how they managed to like overcome them? I mean, how did they pull all this off?
Well, I mean, first off, they had to build this spacecraft that could survive.
Right.
The intense temperatures and radiation of deep space
Right.
for decades.
Yeah.
And they had to do it with 1970s tech.
Right.
I mean, these probes were like built to last with backup systems and tough materials.
Yeah.
They had to be able to handle anything space could throw at them.
Wow.
And remember, this was before we had powerful microprocessors.
All right.
So they had to come up with incredibly efficient software
Great.
using, clever algorithms and data compression tricks just to make the most of that limited computing power.
It's almost like they were coding poetry, like squeezing the most functionality out of every bit and byte.
Yeah, that's a good way to put it. And then there's the whole communication challenge.
Oh,
We've talked about the signal delay.
Yeah.
But imagine trying to communicate with a spacecraft that's billions of miles away
Right.
with 1970s tech. It's incredible that they developed these like super sensitive receivers and transmitters
Yeah.
and powerful antennas here on Earth just to like pick up those faint signals from the Voyagers.
And they also had to account for the Doppler effect too, right?
Oh, yeah, absolutely. It's like trying to hear a whisper from a speeding train.
Yeah.
But, I mean, they figured it out. They came up with all these sophisticated ways to adjust for those shifts in the signal's frequency
Wow.
and make sure that the communication was clear.
It's incredible when you think about all the problems they had to solve.
Yeah.
All the the unknowns.
Right.
That they had to face. I guess it's true what they say,
Yeah.
Limitations really do breed innovation.
Yeah, I mean, the Voyager missions are like the perfect example
Right.
of what human ingenuity can do.
Yeah.
Even when faced with these seemingly impossible challenges. It's also important to remember it wasn't just about the technology.
Right.
It was about the people.
The people.
All those, the hundreds of scientists, engineers, technicians,
Yeah.
the support staff, they all dedicated years of their lives
Yeah.
to make this happen.
It's so true. It's easy to get so focused on the, the nuts and bolts of it all,
Yeah.
the hardware, the software.
Right.
But ultimately, it's the human element, right?
Yeah.
It's the passion, the dedication, the collaborative spirit that really makes these extraordinary endeavors possible.
Yeah, you're absolutely right. The Voyagers are really a testament to, the power of human curiosity,
Right.
our ingenuity,
Yeah.
and our ability to work together. And their story, it shows us what we can do
Yeah.
when we come together, and work toward a common goal.
And what a goal it was.
Yeah.
Sending these emissaries out
Yeah.
to explore the solar system and beyond.
Yeah. It's amazing. And it almost feels like we're talking about them like they're, living things.
I know.
It's kind of strange.
It's like they represent something so much bigger than themselves.
Yeah.
You know, they really embody that, like, human desire to explore,
Yeah.
to push the boundaries of what we know,
Right.
to connect with the cosmos on this, like, deeper level.
Totally.
Speaking of connecting with the cosmos, I'd love to talk about the Voyager Golden Records.
Oh, yeah.
There's such a unique and fascinating part of this whole mission.
Right. It's like a message in a bottle
Yeah.
packed out into the universe.
Yeah. So they have sounds and images of life and culture here on Earth.
Right.
It's such a beautiful gesture.
It is.
Like optimistic, you know? It's
Yes.
like saying, hey,
Yeah.
we're here.
Yeah.
This is what we're like.
This is us.
Yeah.
Yeah. It's been into that human need to connect, doesn't it?
Yeah.
Even across like unimaginable distances.
Oh,
And
yeah.
who knows, maybe like millions of years from now, some alien civilization will stumble across one of those records
Right.
and be touched by our message.
That would be incredible.
Yeah.
It would mean that their legacy, like, extends far beyond us.
Right.
And our own time.
Yeah, it would be amazing.
So should we dig into those a little bit?
Yeah, let's do it.
I think our listeners would be fascinated to hear about the thought and the care that went into these messages
Yeah.
and what they might mean
Yeah.
to any extraterrestrial out there that stumbles across them.
Yeah, absolutely. I'm happy to talk about it.
Great. So let's move on to the next chapter of our Voyager story.
Okay.
Explore these golden records.
Yeah.
And the hopes and dreams
Right.
that they carry for humanity.
Awesome.
So we've been talking about the Voyager's incredible journey, from those groundbreaking discoveries in our solar system to their current mission out in interstellar space. But as they start powering down,
Okay.
it makes you think about their legacy.
It does. What will these little spacecraft, launched back in the 70s, what will they mean to humanity hundreds, even thousands of years from now?
It's a huge question. Where do we even begin?
Well, I think one of the most profound legacies is the inspiration. The Voyagers, they remind us what's possible when we really set our minds to something audacious, even if it seems impossible at first. I mean, generations of scientists, engineers, even just dreamers, they've all been inspired by this mission.
Yeah, I can definitely see that. It's like they've expanded not just our knowledge of the universe, but our imagination too. And they've kind of changed our perspective, haven't they? Knowing that there's this little piece of humanity out there, pushing further and further out into the vastness of space.
Exactly. They represent this turning point. In our relationship with the cosmos, the Voyagers, they were the first to really explore the outer solar system, and now they're out there in interstellar space. It's like humanity taking its first baby steps out of the cradle.
It really makes you wonder, what's next for space exploration? Will we follow in their footsteps and send more probes out to interstellar space, or maybe even humans one day?
It's hard to say for sure, but I think the Voyagers have paved the way. They've shown us what's possible, and they've given us the knowledge and the drive to keep pushing those boundaries.
But even if we never send another probe, beyond the heliopause, the Voyagers have given us this incredible sense of perspective. Wouldn't you say? I mean, we're on this tiny little planet orbiting this average star in a galaxy full of billions of other stars.
And the Voyagers are out there right now still traveling, still pushing outward, carrying our hopes and dreams with them. It really is humbling and awe-inspiring.
It is. It makes you realize that even though we're just this small part of this vast universe, we have the capacity to do amazing things.
And to learn incredible things, the Voyagers have shown us that there's still so much out there to discover, and that this journey of exploration is really just beginning.
Speaking of journeys, one thing that always fascinates me about the Voyagers is that golden record they carry.
Oh, yeah, the famous Voyager Golden Records. It's like this time capsule, a message in a bottle thrown out into the cosmic sea.
Exactly.
Yeah.
They contain sounds and images that represent life and culture here on Earth. It's such a beautiful gesture, so optimistic, like saying, hey, we're here. This is what we're like.
It speaks to that deep human desire to connect, doesn't it? Even across these unimaginable distances. And who knows, maybe one day, millions of years from now, some alien civilization will find one of those records and be moved by our message.
That would be incredible. It would mean that the Voyager's legacy extends far beyond our own species and our own time.
It would be a true testament to the power of human curiosity and creativity. And I think it's important to remember that even though the Voyagers are starting to power down, their journey isn't really over. They'll keep traveling through interstellar space for billions of years, carrying those golden records with them.
They become these cosmic ambassadors representing humanity on this grand stage, and this story of exploration and discovery and ingenuity, it will continue to inspire us for generations to come.
It will. So, as we wrap up this deep dive into the Voyager missions, we'll leave you with this thought. Even though the Voyagers are powering down, their legacy is just beginning, their journey continues, and their story will keep unfolding as long as humanity is around to tell it.
What a perfect way to end our exploration of the Voyagers. It's been a privilege to share their story with you, and we hope it's left you with a sense of wonder and inspiration. Until next time, keep looking up.